This is question 2 from the third CSAT sample paper, and in this question we are asked to prove that 12 divides n to the 4 minus n squared, where n is any positive integer. So if you haven't seen this notation before, this just means the thing on the left is a factor of the thing on the right, or the thing on the left divides into the thing on the right. Okay, if you want to have a go at this question yourself, pause the video now. So what are we looking for in this question? Well, it's an integer question, and we're explicitly told it's about factors. So let's think about the factors of 12. And 12 is quite a big number to think about the divisibility of, but if we break it down, that makes it easier to work with. So in particular, it's equal to 4 times 3, and 4 and 3 are both reasonably small numbers to work with. And it's enough to show that 4 and 3 are factors. One thing that can make that even easier for us is, what does it mean for 4 to be a factor? It means 2 has to be a factor twice. So there are 2 factors of 2 in this expression. That's what we're looking for. So another thing that makes this useful is that 3 and 4 are what we call co-prime. They don't have any factors in common. So if we show that 3 goes in and 4 goes in, because they can't share any factors, that immediately means that 12 goes in. Whereas, for instance, if we broke it down into 2 and 6 and showed that 2 goes in and 6 goes in, well, there are numbers that 2 and 6 go into, but 12 doesn't, like 6 itself and also 18 and other multiples of 6 that aren't multiples of 12. And that's because 2 is itself a factor of 6. So, for instance, if we look at 18, then 6 goes into that, and because 6 goes into 18, 2 goes into it, but 12 doesn't. And that's because we only have one factor of 2. So we're looking for 2 separate factors of 2. Okay, so now we want to know the factors of this, so now let's look at this and its factors, and then think about how we can show these small numbers go into it. So n to the 4 minus n squared, well, the easiest factor to take out is n squared, so we take out n squared, get n squared times n squared minus 1. And also this is a simple difference of 2 squares, so you should recognise you can factorise that into n minus 1, n plus 1. And then how can we start thinking about the small factors of this? Well, hopefully something you've seen is that if I have 2 consecutive numbers, so I call them n and n plus 1, and I multiply them together, well, 2 is going to be a factor of that. And that's because if we have 2 consecutive numbers, one of them has to be even. The first one's odd, the second one's even, and vice versa. And if we have 3 consecutive numbers, then one of them has to be a multiple of 3, and therefore 3 goes into the product of any 3 consecutive numbers, and etc. So if you have 4 consecutive numbers, 4 goes in, etc., etc. Well, we don't have 4 consecutive numbers here, so we can't jump straight to 4 being a factor. But we can get 3 consecutive numbers. So if I take out just one factor of n and then rearrange the other 3 factors from here, we get n minus 1 times n plus 1. That's 3 consecutive numbers, so 3 is going to go in. And then, okay, we can't get 4 going in directly, but again, we can look for 2 going in twice. And if we rewrite it as this, so n minus 1 times n, and then n times n plus 1, then we've got 2 pairs of consecutive numbers multiplied together. So 2 goes into each of them, and they don't share any factors. This is 2 separate factors of 2, and that means 4 is going to go in as well. So that means that, from what we said before, 12 is going to go into the whole thing.